So today is lesson 12. We're going to have a bit of a shorter lesson today. We're going to work with APIs, both consuming and creating APIs. But just before we dive into that, I want to talk about next week's final exam. So the exam is written during our regular class time. So it will open at 11 and you'll have to submit by 2 p.m. You will still want to sign into the WebEx room. I'll be sure to open the WebEx room by 10:50 next week. And if you have questions during the exam, you can just use the chat to ask any questions. The format of the exam is all practical. So if you think back to the practical section of the midterm, it will be similar to that, but larger. There's no quiz questions. There's no multiple choice at all. There'll be several different versions of the exam. So not everyone is going to be given the exact same set of requirements for it. And then to submit your exam, you'll submit it the same way you've submitted your other assignments for me. You'll just submit your GitHub and your AWS link on Blackboard. You don't actually have to upload any code. One of the other things that I'm going to have you do is during the exam, every half an hour, I'm going to have you commit your code to GitHub. So that way I can see your progress through the exam, because obviously we're not in a classroom together, so I can't actually see what anybody's doing at any particular time. So you'll have to make 6 or 7 commits through the exam, and then your final commit by 2 p.m. Pretty much the entire content of the course can be covered in the exam. I'm searching my brain to see if there was anything else I wanted to say about it. I think I've covered it, but if there are questions about the exam, then please go ahead and ask. It will be the same format as the practical section of the first one. The midterm exam, remember, was a combination of multiple choice and practical. There is no multiple choice on the final exam. Only practical. So you'll have 3 hours and you will be coding for all of it. Does anybody else have any questions about next week's exam? No, David, there really isn't anything you need to do in advance. Not that I can think of, no. Any other questions?
All right, so how long is the exam?
It's 3 hours.
Okay.
It's just our regular class time. It's just in our regular class time. So you have to submit by 2 p.m.
Okay.
I'll also encourage you. So we've got about half the class here today. The other half isn't here. And a lot of people trickled in a little bit after 11. I would recommend you're in the WebEx room before 11 because I'm going to go over the exam instructions next week, some of the details right at 11 a.m. And you want to maximize the amount of time that you have and your exam is due at 2 p.m. regardless of whether you arrive in class on time or not. So you don't get any extra time if you show up late. So I'm going to encourage you to show up early to give yourself as much time as possible. If other questions about the exam come to mind during today's class, then by all means, use your mic or use the chat and let me know. So today we want to talk about APIs. We're going to introduce them, do a little bit of a 1,000-foot view, what an API is and how they can be used. We're going to implement a couple of simple APIs into our PHP gaming site. And then lastly, we're going to create our own API that displays data in JSON format. So we've already talked about code reuse before, and we've implemented it in our PHP gaming site with things like include and require, so that we could share pieces of code or visual components among different places on the site, right? But there are some other ways that we can make our coding less intensive and also extend the functionality of our site. So there's lots of freely available code that we can use that others have written and published that we can incorporate. Can you think of any examples of sort of third-party code or extensions or libraries that we might commonly see when we're using websites? What are some examples of these external services that websites might use? It's not very useful. See if we can go to the main Georgian page. So where or why would a website use an external service? Help if I could load the Georgian site, which I can't. Okay, so social media. Yep, Colton, social media, they offer lots of services. So not just links, but what kinds of functional components do social media providers offer that we might include in web applications we're building? You're on the right track when you say social media. Okay, so like something like a Twitter feed, exactly, right? We're not going to write our own Twitter feed. We're going to use Twitter's API so that we can include a Twitter feed in our own website. Great example. We think of some other examples besides using Twitter's API so that we can show Twitter data in our website? What are some other common examples where we can use a third-party service to add functionality into a site we build? Think about authenticating users. What's a really simple way to authenticate users using some kind of third-party service? We've written our own registration and login code. How else could we do it that might be even simpler? So these third-party services are what's called, Colton mentioned the name already, are called APIs, which stands for Application Programming Interfaces. The name's been around for a long time, but put simply, an API is just a way for two different applications to communicate in some way. So again, if we go back to Colton's example, it would allow a custom web application maybe that we build to communicate with Twitter so that we could use Twitter data within our own site. The APIs also let us extend our functionality by including functionality from other applications. So we see APIs all the time. APIs serve as the bridge between different applications. So here would be some other common examples. So Google makes a whole bunch of APIs available. You can include Google search in your own website. So a site like here, if I search The Guardian, or right, it says right in here, actually, let me just refresh that. We know that the search is actually using Google's API. So if I search for something on The Guardian, right, we can tell they haven't coded the search page itself. It looks like Google and it's actually branded with Google. Google Maps, Google Login, Facebook Login, all of these are APIs. When we want to pay with credit cards, we're not going to write the code to check if someone's card has room on it and actually charge it. We're going to send that credit card information to a third-party service, a payment gateway API, and it will take care of the payment for us. We want to do graphing and charts. We want to show real-time data like a stock ticker or news feed. Again, we're going to find an API that we can plug into and we can use in our own site. No, there was no quiz.
Okay, thanks.
Actually, sorry, let me check that. Yes, I'm sorry, there was a quiz on file uploads. Yes.
Oh, right. It was
Actually, sorry, hang on, Chris, just a minute. This quiz was not due. No, there was no quiz this week. I apologize. Sorry, no quiz. That's 2020.
and also last week.
I don't believe there was a quiz last week either, no.
Okay. Just check. Thanks.
So the name API, it's kind of become a bit of a misnomer. The name is almost 30 years old. It comes from the early 90s when Microsoft first developed Windows. So the idea was Microsoft, and this is kind of a screenshot, there's a little video here describing it. So when Microsoft created its first graphical operating system, they had the idea that there was certain functionality that every program needed that they were going to build into the operating system. So features like saving a file or printing a file. So they built features like save or print as these separate individual programs. So if you wrote your own application to run on Windows, you didn't have to create your own save or print methods. You could just use these services, these part of the Windows operating system. So this level of kind of shared public services were known as application programming interfaces. So even though APIs today mean a much broader thing, we've kept this name. The name has kind of persisted for 3 decades. So a program like Word could interact with the print feature of Windows with that API. So again, two programs communicating in some way. So we don't necessarily see APIs as much in small web applications, but in large applications, many large-scale applications are really collections of different programs or different applications that use APIs to communicate. So this is especially true. We see this in web applications, in mobile applications, in Internet of Things devices, right? Those devices, though, any smart device, it's all API based, where it can read and send and write data. So the idea is APIs let us share data, extend functionality, and it reduces development time and cost, because we're taking code libraries that are already working and integrating into them into the things we're building. So it's important, if we're going to be developers, we need to know both how to consume, how to use an API that was created by someone else, but we also need to create our own APIs. So this is a critical skill for modern developers. We're going to play around with it a little bit today, and we'll do more work with APIs in our next course in September, in our server-side scripting course. Here's a real-world example. This is the architecture of both a web and mobile platform for one of the major Canadian banks. So each one of these boxes represents an individual application. So this is their web banking portal, their mobile app, some third-party apps, their administration for the employees of the bank. These are all the front-end UI components. These are all the different components and services in the back end, different databases, security layers, their content management system, caching, bill payments. They have all these different services. It's not just one program that runs everything. And some of these programs they build, and some of them they actually just go ahead and buy pre-existing software. So everywhere you see arrows or lines, these represent the APIs that allow the different components to exchange data and talk to each other. So you can imagine how much work is involved in the creating and consumption of APIs. So it's a huge part of what the developers that would put an application like this together would be doing. So most APIs, it doesn't matter. One of the nice things about APIs is they allow two programs to talk to each other, even if those programs were written in entirely different languages, running on different frameworks, different operating systems, because APIs tend to speak common language for moving data back and forth. The original standard was XML. And probably for the last 10, 12 years, the current format is JSON, which fortunately you guys have already started working with, probably in your client-side scripting class. Probably have some familiarity with JSON already, right? It's a basically nested JavaScript array, JavaScript object notation. So we tend to use JSON more than XML these days. It's easier to read. It's also lighter, so fewer characters, which means the files aren't as big, so we can transfer data faster, and it uses less bandwidth. So as a quick sample up here on Blackboard. So here's, for example, a representation of a person in XML, but in XML we have opening and closing tags. In JSON, we only have a single tag for each element. So when we have a lot of data, representing that data in JSON is going to be fewer characters than the same representation in XML. So most modern APIs use JSON for sending and receiving data. So for example, we might have an iPhone app that's typically written in Swift, but we could add something like a Microsoft login to that iPhone app, and that API is written in C#. But because both of them can speak JSON, they can pass login requests and responses back in JSON. Doesn't matter that those two applications are written on entirely different platforms, because JSON is kind of the common language, the common delimiter. So we're going to work with we're going to add some APIs into our PHP gaming app, and then we're actually going to build our own API. I can actually sketch out one other simple example. To illustrate how this would work in a real world context. So years ago, I built an e-commerce site for a customer. We had a shopping cart. People could shop online and they could order the products. And what would happen, so we had our site, and my customer had about 12 different suppliers of the product. So what would happen is when we first built the site, at the end of the day, he would pay one of his employees to go through and query the database to generate a spreadsheet of all of the orders for each supplier, and she would email them out. So she'd have to generate 12 different spreadsheets and email those out to 12 different suppliers, and eventually said to me, look, I'm tired of paying somebody. Once I get an order, I just want that order to automatically get sent to whoever's making that product. He sold linens and things, so he said, my pillow manufacturer's over here, my towel manufacturer's over there, my sheet manufacturer over here. If someone orders a pillow, a towel, and a set of sheets, I want each product to automatically get sent. So then we had each supplier created an API to receive orders, right? So we got the orders. Actually, I should probably do this as a diagram. So over time, we built a collection of APIs. Easier like this. So here was our site. So then we had the suppliers. Supplier 1. So every time an order would come in, struggling with my lines. Every time an order would come in, so each one of these would be an API, right? The orders would go out. So we would push the orders to their APIs. Then the suppliers, they would make the products and they would ship them out, and they would need to send the tracking numbers back. So this would be tracking. So I had to create an API that could accept the order number and the tracking number. So I pushed data to their APIs. When they shipped orders out, they pushed the tracking number back. Then my customer started selling their products on the shopping channel. So people could watch the shopping channel, see the products, call and get an order. The problem is we then needed a way to get those orders into our site. So what did we do? We built a new order API. So every time someone called the shopping channel, that order automatically flowed into our database. We then pushed it to the suppliers who sent the product out and then pushed it back. So it became this ecosystem where we had these different applications, all written in different programming language, that could move data seamlessly, electronically, and automatically with APIs. I know I made a mess of my diagram. but I think you get the idea. So this is really common in any kind of electronic commerce. We have data that needs to move from one place to another. So APIs are the mechanism for doing that. So let's open up our PHP gaming site. We're going to work with first one really simple API, and then we'll work with one that's a little more advanced. So I'll open up my site. So what we want to do on our home page is we're going to use an API to display the current weather. Right? So something like this. We might get a little icon and we'll get the current temperature. So for us to create all that code ourselves, for us to figure out how do we get the current weather, write it all, would be next to impossible. But fortunately, there are APIs available to help us do this. So in the lesson 12 folder, there's an item here that says weather widgets. So open that up. It'll take you to this site, booked.net/widget/weather. It should default to our current location in Barrie, or if you're somewhere else, should default to your location, but you can also manually change the location. So there's a whole bunch of different weather widgets here. I maybe just want, I like this one, this little weather sticker. So I'm just going to click Get HTML Code. And then if I just click here to copy it, it's basically just a bunch of JavaScript that loads the current weather from their API. So I'm going to copy that. And I'm maybe just going to put this right on my index page. So underneath what's here, I'm just going to paste that all in. And it's got a comment already. And now it shows on my homepage. It now shows the current weather. And you can customize it if you like. You can change, the color, or you can change the size. The border type. So there's the world's simplest consumption of an API. Find a service, copy the code, paste it in. And now our homepage is going to show the weather with no coding of our own. We didn't have to create anything. Anybody have any questions so far? So there's like the world's simplest example of consuming an API. We're going to add a more advanced API next. And we'll start now. It'll take us into the next hour of class. And then we're going to create an API of our own. So we're going to add an API here on the register page. One of the challenges when we build forms on public web pages is spam, right? When we publish this page, when I upload this to AWS, there's a good chance we're going to get a lot of spam and bots filling out our form because it's a public page. So what could we do? How can we help prevent bots from putting junk in our web forms? There's a popular API that's available that we can use to help prevent this. What API have you used that tries to validate that you're actually a person and not some kind of automated service like a bot? Yeah, robot check. Right? That's right, Colton. And there's a few different services, but what's the really popular API that does this? What's it called? It does start with an R. Thank you, Colton. It's the Recaptcha service, which is now owned by Google. It started out as an academic project, was created by some university professors in Pittsburgh, and Google bought Recaptcha quite a while ago now. So we want to add Recaptcha, and there's different versions of it, but we want to add it to our register page. Okay, so it'll look something like this, showing you the example that we did in my class yesterday. We want this little Recaptcha that will check and make sure that the user is likely a human being and not a bot. So we need to go to the Recaptcha site, which is here. It's on Blackboard, this Google Recaptcha Anti-Spam for Forms. So open up that link. You will need to use a Google account for this in order to use. So Google has lots of APIs available, but you do have to register with Google. So you need to use a Google account for this. So Recaptcha protects your website from fraud and abuse. It uses risk analysis to try to determine whether the users are legitimate or fake. Now, the new version is frictionless, meaning the user doesn't actually have to do anything. In version 2, this is when Recaptcha gave you, so there's been 3 different versions of Recaptcha. Version 3 just looks like this. And it just automatically does a score. Does anybody happen to remember what do earlier versions of Recaptcha look like? Both of those required the user to actually do things. What did version 2 and version 1 of Recaptcha look like? That was version 1, David, yes. So they gave you difficult to read letters and you would have to retype them. That was the original kind of version of the project. Version 2 was this, right? So Google was using them largely for verifying Google Street View and for autonomous vehicles. They were getting people to identify physical locations and what they saw. So Google could use them for Google Maps, Google Street View, and potentially for autonomous vehicles. Recaptcha 1 which was the original version, this was actually a little more interesting. So look, David, I think this is what you're thinking of, right? Where it would show you text that was hard to read. And the text, the whole way that Recaptcha was actually created, the professors who created it, they created it because they were scanning old texts, excuse me, that were hard to read. So the idea was when people confirmed the letters, that let them digitize old texts. And Recaptcha was not only used to prevent spammers and bots, but it was a way of digitizing old texts. That was the original purpose of it. Once Google bought it, they changed it to their own purposes, where they were using it for like its geo services. And this was kind of intrusive and difficult for users. So version 3, which has been around for a few years now, it's simpler because as a user, I don't actually have to do anything here. Google will just automatically use its algorithms to try and figure out if I'm a bot or an actual person. So if we click, Get Started, see if this takes us where we want. No, we don't want to click Get Started. This takes us into Recaptcha Enterprise, which is actually now a paid service. Recaptcha's always been free. Google has decided they now want to charge for it. We'll just stick with version 3. So we'll go to the version 3 admin console. Right. I feel you, David. So what we want to do here is we want to create a new site. So I have used Recaptcha on 25 different sites, both some version 2 and version 3. You probably won't show you any sites here, so just click the plus sign. We're going to create a new site that uses Recaptcha. We'll give it a descriptive name, so I'll just call it PHP Gaming. We're going to use version 3 so that the user doesn't have to try to answer some kind of visual challenge. And then it wants our domains. So I'm going to put in 2 domains here. We've got localhost as 1, and I'll hit the plus sign. And our other domain is computerstud.es. So this version of Recaptcha, our website will run on either one of these domains. So our domains are localhost, and I'm putting it in the chat, computerstud.es. So we've given our site a name so that we can distinguish it from other sites. We're going to use Recaptcha version 3, and our domains will be localhost and computer studies. It'll show the email address associated with your Google account. You need to accept the terms of service in order to use it, so just check this box. If you want, you can keep this checked. Google will alert you if there's misconfiguration or an increase in suspicious traffic. I'll just uncheck it for now. For right now, I don't need that. I could always go back. If this was a live site, I could go back and turn this on. Okay, so a name, version 3, localhost in computer studies, and accept the terms. And then we can just click submit. So it says PHP Gaming has been registered, and it gives us 2 key values. So whenever we're working with APIs, most of those APIs want some way to identify. So we get a site key. This value is public. It's going to go in a client-side JavaScript that users could actually see in the source of our page. We then have a secret key, which will go in our PHP code that's going to send our Recaptcha request to Google's API. And Google will send us back a success or false response. Okay, so I'll just keep this open. And then we need to do the client-side integration on our register page and the server-side integration on our save registration page. And Google gives us some code samples, but they don't work exactly the way I want them to. So we're going to write the code ourselves. So let's open up. I'm going to close all the other pages. So the only page I've got open right now is my index page. So I'm going to open up register and save registration. These are the only two pages we need for Recaptcha. So the first thing we're going to do in our form is we're going to put a hidden field for the Recaptcha response. So this little JavaScript that generates this, it's going to generate a Recaptcha response that we want to include when the user clicks register. So before my end form tag, I'm going to add a hidden input. I'll call it Recaptcha response. And this has to go inside of our form. So we'll put that at the bottom of our register form. Doesn't really matter where it goes as long as it's somewhere in between the opening form tag and closing form tag. I just put it right at the bottom. Then we're going to call the API that will generate our little Recaptcha symbol here, and we'll write a response into our hidden field. So there's two steps to this. First is we're going to link to the API, and the URL is pretty simple. It's google.com, Recaptcha, API.js. And this is where we now have to add on our site key. So it's tying our web page to the Recaptcha site that we just created in the Recaptcha panel. So render equals, and then we're going to copy our site key in here. I'll put this in the chat. But I need to replace this, your site key here. I need to replace that with the site key in the Recaptcha console. So I can copy it. My browser says it's copied. And then I'm going to replace this placeholder of your site key here. I'm going to paste my site key in here. So you'll use your own site key after the equal sign. So Chris, once you submit your site in the Recaptcha admin site, it will take you to this page. If you can't find it, if you're back here, once you've submitted it, on the settings page, the keys are also here. So you can just expand the blue Recaptcha keys. And there's your site key. So just click copy. You have to make sure you click submit at the bottom. The keys don't get generated until you click submit. Does that help, Chris?
I'm not sure it's helping because all I did was click get started, and all I see here is the Recaptcha Enterprise.
Okay, yeah, you don't want to click get started, so click back.
Okay.
So when you click back, you want to click this version 3 admin console instead.
Oh.
And then you click the plus sign to create your site. So now you should have this page that says register a new site. And you can give it a label. You choose version 3. And I've put the domains in the chat. And then you just click on accept terms of service, and it will generate your keys at that point. So if you refresh your register form, notice now I get our little Recaptcha icon showing up in the bottom corner by calling this JavaScript.
Oh. So I got an error. It says the following domain is invalid. Localhost and computer stuff. Yes. Local host.
So it should just be localhost like this.
Okay. Got it.
And if the site key is not valid, so I'll just put mine back here to say, you know, your site key here. If I refresh, it won't show without a valid site key. So once I put in the valid site key, my Recaptcha will show up. Whoops. Oh. Just put it back. So I'll get my key again and just put it back in. Okay, so this is only the first part. So this shows up. We've got our hidden field for the Recaptcha response. We'll have to do 2 more things to make this work, which is what we'll do after we take a break. Number 1, on this page, we'll need to write a little bit of jQuery, a little bit of JavaScript, so that the Recaptcha executes and puts a response into this hidden field. And then on our save page, when we're validating the inputs, we're going to need some logic here to send that response to Google, to the API, and the API is going to return information, and it's going to tell us whether the user is likely a real person or a bot. And if it's a bot, we're going to show an error message, and we're not going to let them sign up. But we will do that after we take a break. So I will push, we haven't done a lot of coding today, but I'll push what we've done so far up to GitHub. We'll take a 10-minute break, and we'll come back at about 12:02.